All right, so we've got to look at this polynomial and show that we can express it in that form. So what we can do is expand out that form and equate the coefficients. So if we have a look at this polynomial, if I write this one down and equate it to the expansion of this, let's just expand it first. So we've got x squared all squared, so 4 minus double the product, so 2ax squared, square the last term, and same here, square the first term, minus 2bx and plus b squared. So you can see there that we're going to get x to the 4, right? That's that one. Now, x squared wise, we've got this bit and this bit that are x squared. So if I have a look at that, that's 1 minus 2a, lots of x squareds. So 1 minus 2a, lots of x squared. If I look at the x's, so I might get rid of that. Get rid of that. All right, so looking at the x's, I've just got negative 2bx. And then that's that one, and the rest of it is constant. So I'm going to get a squared plus b squared. That's going to be the constant. All right, so clearly, here we go. You can see 1 minus 2a has to equal 1 minus 2a. Has to equal the coefficient of x squared, so we have minus 5 there. So if I add 5 to both sides and add 2a to both sides, I get a is equal to 3. And then if we look at the coefficient of x, so here we've got from this bit here, we've got minus 2b's has to equal the coefficient of x, which is positive 4. So dividing by minus 2, we get minus 2 for b. And then if I look at this section, this has to be the constant. So we've got a squared plus b squared equaling 13. Of course, I don't need to find that, do I? Because I need to find a and b, and that's not helpful anyway. So ignore that. All right, so now we know that we can express this polynomial. Instead of in this form, we can express it as x squared minus a, so that's 3, squared plus x minus b, so that's positive 2, all squared. And that's interesting because you can see this is something squared and something squared. Now anything squared is going to be positive. So unless we have zeros, so p of x is always, at the moment, we know it's greater than 0, except we need to just check when these brackets are 0. So to make these brackets a 0, you can see, when x equals minus 2, that bracket will be 0. If I look at the other bracket, so p of x, p of negative 2, let's have a look at that. So we're going to get, if I pop it in here, negative 2 all squared is 4, 4 minus 3 is 1, and 1 squared is 1. So we're going to get 1 plus 0, so we're just going to get 1. So that's still positive, so that's all fine. If I make this one 0, then my x squared would be equal to 3. So if you think about it, my x is actually equal to plus minus root 3, but I can use the squared there. So p of, I'm going to put plus minus root 3 here. I'm going to do both at the same time. So you can see that if I put it in here, if we put plus minus root 3 in there and square it, we get 3, minus 3 is 0. So we're going to get 0 plus, and here we're going to get 2, I don't know if you can see these things keep popping up. Yes, I want to quit, thank you. All right, so you get 0, so plus or minus root 3 plus 2, and it's all squared. Now, even if I minus root 3, it would still be a positive number anyway, and we're also squaring it, so we're getting a positive number. So this, sorry, I can't fit it on, but that is going to be a positive number. And we know 1 is also a positive number. So we can say that this polynomial is always positive for all x, for all values of x. If it's always positive, what does that mean? It means wherever it is, it's always above the x-axis, right? It's always positive. So when it then asks how many x-intercepts does this polynomial have, of course it doesn't it doesn't cross the x-axis at all, so it's got no x-intercepts or no real roots.